All right, we're a little bit ahead of the game today. So what I'm going to do is I'm going to begin a discussion on deployment of Java. In other words, how do we get our Java code out to the rest of the world to execute and to run and so on. We certainly wouldn't want to give everyone our Java source code and have them compile it and execute it. And even running our Java class files could be difficult for people, so we have several choices as far as how to get this out to the outside world. And let me describe them in a little more detail. These are different ways that Java can be deployed. By deployed, I mean made available to the end user. One of the ways is that a jar file can be created. Java archive, I believe jar stands for. And it can be created and an installation program can be written that will install a program, I'll say application, on each client. In the past, that was certainly the way that it was done prior to innovations such as web and Android. The disadvantage of this is that every client needs the JRE, the Java Runtime Engine, and they need a copy of the jar. And again, typically you would have an installation application that would install the application in a certain location and make whatever other system updates were required to make it work. Now, one of the issues with this is in terms of updating the application, because if there was a change made to the application, again, this is in the past, people would have to download a new copy of the jar and reinstall it to take advantage of it. I didn't work in a Java environment on this project, but I worked in an environment where we had an application for our company's field engineers, people that went out to repair machinery at different manufacturer sites, and being able to tie down a field engineer and get them to download and install a new version of the program was actually very difficult between their traveling, their long hours repairing the machines, and so on. It seemed that getting them to find some time to download and install a new version of the application was difficult to do. And with the jar, with this process, with the version of the jar being on every client, every user's machine that used it, this is an issue. All right. The advantage to that is you can work without being connected to the internet. So in our field engineer example, we went with that strategy because at least at the time, a secure, good web connection was not to be assumed for the people that were using our applications. In the factory, they weren't able to ensure the fact that they would have a good internet connection. So having their program locally installed on their own machines was a way that they could work on the application with everything local to their machine, and they didn't need an internet connection. So this is the oldest strategy for deployment, and we'll talk about it a bit more as we go forward. One of the things that we'll talk about is how to make the jar, because it's a process that you go through there's a process that you go through to create a jar. Some of these things get to be complicated. The larger the Java application, the more complicated it is, the more dependencies there are. that is code that your code needs to make sure that it runs correctly. And therefore, there's a bunch of different management schemes. So at this point of the class, we're going to sort of move away from doing everything at the command line and use an IDE. And we're going to look at Netbeans coming up in a few minutes here after we give an overview of all these different strategies. Another way is to deploy your application via the web. All right. In the case of the web, we have our clients, and all our clients need is a browser. They don't need a jar installed, and they don't need the Java runtime engine. They will be connecting through the internet to a web server. And this server can run one of a couple of different technologies that are Java-based. And they are JSP, Java Server Pages, or Java Servlets. We'll preview what some of these look like either in this class or going forward. But essentially, this is server-side code. And if you remember from your other classes that you probably have taken, with server-side code, the web server doesn't have finished web pages to be delivered directly to the client. Instead, there are scripts, there are instructions that are written that take and process those instructions, maybe interacting with the database. These are input to the server along with the database, and the output produced are HTML, CSS, and JavaScript. JavaScript, of course, is different than Java. JavaScript is a tool that typically is used for client-side programming, but it can be used in some cases on server-side programming, but we're not talking about that here. We're talking about pure Java-based solutions. All right, the client then, this is known as a thin client, because the client doesn't require extensive hardware to run Java or the Java jar or the Java runtime engine. They interact through the web browser, and all the Java gets executed on the web server. Now, there's sort of a different architecture at work here. There has to be a way for the web server, there has to be add-ons to the web server to allow it to understand Java and so on, but it is possible to do that. And two of the technologies for developers to do that are JSP and Java Servlets. They're both the same thing in principle. They sort of approach the problem from opposite directions. JSP are pretty much HTML page with Java interjected in the middle of them. Whereas Java Servlets are Java classes that have HTML injected in the middle of them. And we'll not be writing any JSP or Java Servlets in this class, but we will take a look at how you might use them and give a sample of what the code looks like for both the Java Servlet and the JSP page. Finally, we have Android development. And with Android development has currently two languages which can be used, Java as well as Kotlin. Now, Kotlin is growing, and at some point it might be the main language of use for Java. But currently, Java is probably used for more applications than Kotlin is. Kotlin is a new and upcoming language that is used for Android development. But Java is still one of the languages that you can use in Android development. Java development, again, would be sort of almost a mix of the two in a way, because Some of the code is going to reside on the client's device, and it probably will communicate with servers for things like databases and so on. In fact, even with a jar, that might be the case, where your database is not local, but is on a database server that exists somewhere on your network. So these are 3 ways you can get Java code out to the world. In a jar, installed locally on a machine, in a web application, which is done either via JSP or Java servlets, or some mix of the two, and finally, Java Android. All right, what I'd like to do now is sort of preview Netbeans for you. Netbeans is a GUI that's allows you to create Java applications, to run them, to document them, and to deploy them in terms of creating jars. You can also use Netbeans to create JSP pages, Java servlets, all that sort of thing. So, I'm going to start off Netbeans. And I'm going to bring in an example we had a couple of weeks ago, our first GUI that did the Fahrenheit to Celsius conversion. I'm going to show you how to import something that you may have done just with a text editor and in the command line into the Netbeans project structure. So I'm going to create a new project. I'm going to pick Java with Maven and a Java application. It says a simple Java application using Maven. What is Maven? A Maven is a process that controls the building. It downloads code when necessary for an application. For some of the dependencies that it may exist in the application. It can create the jar for you. It can generate Java documentation and so on. So the process of building is good to learn that you can do it from the command line, but you will typically be building your code via Java with Maven or one of these other strategies like Ant, Gradle, or so on. You can also create web applications, which we will not be doing at this point. So I'm going to create a Java with Maven application. Click Next. We have our name of our application, where we're going to put it. I'm going to call the project name First GUI, because that's what we called this exercise. We can put it where we want to put it. We have a group ID and a package name. All right, one thing that is possible to do is it's impossible to integrate into your code that other people have written. All right. For example, there might be a library of code out there that is beneficial that I find out on the web and is available via open source or something like that. And I can take that code and use it. How do you keep your code organized? Because you don't want to put all of your Java classes in one place. You divide your Java classes into packages. So if I want to use code that, let's say, someone at CISS226 used or created, all right, what they would have is they would have a package for me. I could download that package and use it. Well, how do I make sure that my code doesn't have some of the same class names as the code that they've generated or some other package that I'm using? What you do is you qualify your code by putting it in a package. And that way you can refer to, if there was two customer packages, classes, for example, you could say based on the package name that you want the customer class that's in your package and not CISS package or something else. So that's what the package name is. It's a way of guaranteeing that your classes are going to be unique worldwide. Because what you use is you use the reverse URL method. And the thought is if everyone does this diligently, everyone is going to be, all their things are going to be keyed based on the name of the organization and their URL that's used for them. And therefore, everything will keep separate. So if I was doing this and I was managing a team of developers in LC, the group ID would be edu Lorraine CCC baby.java or something like that. This is known as the reverse URL. There is only one lorraineccc.edu in the world. So as long as I use that for my package names, all right, I shouldn't have any possibility of running into interference with anyone else's package names. All right, because they should be using their URL. So if I tried to use a package from Tri-C, then their group ID would be edu dot, I don't know what their URL is, Tri-C, something like that. And then you divide from that, you divide it further and specify what package it's going to be in. You could, for example, have a marketing package where your marketing code goes. You could have a utilities package where code that is used in a number of different projects is located. You could have an accounting package where all your accounting classes lived, and so on. So it's just a way of dividing our classes. Our application that we're going to run here is simple and straightforward enough that we only really need to worry about one package. So I'm going to create a package, and I'm just going to say it is edu.lorraineccc.java first GUI, and that should be unique worldwide for the name of this package. So I click finish. It does its work. It generates some of these things. It generates some project files that are used by Maven. Generates the dependencies. This requires JDK 1.8. Java dependencies, other dependencies. And it shows my source packages being in it shows as part of my source packages the package I just created, edu.lorraineccc.java.first-GUI. And it even by default makes a first GUI package for us. So what I'm going to do is I'm actually going to replace the code here that was generated with my code. So I'm going to go and I'm going to delete this guy out of here, code that was generated, because I already have my classes. You could go in here and you could create a new class if you wanted to and change this class and do anything you want. The nice thing about this is it has IntelliSense and all that to keep you from making some simple, straightforward errors. I'm going to delete this. I'm then going to copy. Notice how each section of my package name is a subfolder. So under main, there's edu, Lorraine CCC, Java, first GUI, and all my classes live in there. So I'm going to take and I'm going to post or paste these classes into that folder. And I look in Netbeans, and there they are. From there, I can go and edit them if I want to. And as I mentioned, the nice thing is that there is IntelliSense. So if I want to type in create a new JPanel, for example. If I type in JPanel, shows me that that's not correct because it's actually JPanel with a capital P. If I forgot the parentheses at the end, it will show me that that's in error. And it will tell me that it was expecting a parenthesis. It's a nice way of checking your code before you run it. One thing I should do, because I've just brought this in from code that was created elsewhere, is I should define that the package for this class is edu.lorainccc.java.firstGUI. It'll do that if you created the classes inside. And a period instead of a semicolon. I was going to say, what could go wrong with that statement? But I'm just identifying that this lives in that package, which if you created a new class using Netbeans, it would automatically put it in the new package. So if I like here, right mouse and say, I want a new Java class, call it new class, notice it creates it and it puts it in that package. So I'm only doing this because I have brought this code into my application. It tells you if you have not used an import. So I have this border layout import and I haven't used it. I can run it and up it pops. So 23 degrees centigrade to Fahrenheit is 73.4. 0 degrees Fahrenheit to centigrade is -17, and so on. A lot of students ask me why I don't introduce GUIs at the beginning of this class. I really think it is good to learn really the nuts and bolts approach of doing everything via the command line. And then once you understand everything about Java and the way that it works, then go to a GUI and you can take advantage. It's no different for me than a student who's learning addition and subtraction and learns how to do it by hand first and then goes and uses a calculator. Now, when you compile it, when you run it, it actually compiles it first. You can compile it without running it by going to build. Sometimes if things get out of whack, it's good to clean and build your project. When I run it though, I will get target folder that contains the compiled classes. I'm going to go up here and say build, because that does a little bit more than compile. Build will actually produce a jar file. And a jar file is the executable program that you run and can get the results. Now, I should be able to double click on this and run it, but it's not going to let me. I can double click on it, but it's not going to run. The reason it doesn't is we have not created a Java manifest. You need a manifest to go into the jar in order to run the manifest. So I pulled up this resource, which if this works, I'll post it to Canvas. See, I did not. Specifies how to do it. It says if you include this in your COM XML file, it will create it. So let's test this. Go to my project file. Put that in here. My group ID was .edu. Lorraine, UCC. Java. My main class, which I'll identify here, is save that. Now if I build it, according to this documentation, it should create an executable jar. And there is not. Let's see, here are some of the unrecognized tag. Again. I think I misinterpreted this. Let's try this again. All right, put that in there. Giving me an error. Well, I'll look this up. I'll have a correction for next week about creating the manifest. When you do that, you should be able to deploy that jar to users, and they will be able to take it and run it. Go and get rid of this. Thought it did that automatically, but apparently it does not. Okay, I can't find it here, so let me get rid of all that and I'll rebuild it, and I will look that up for next time. Now, one nice feature of this is it actually creates documentation for you. It's especially useful if you use a lot of comments, because you can go up under generate Java doc. What that does is that generates a set of HTML pages that are very much like the official Java documentation. So if you were to Google Java JPanel, you get code that looks like this format. That's a Java doc file. And it actually generates that for you here. We only have one class, but it generates and it shows you what it inherits from. It shows us the attributes and methods in that class and so on. Nice, valuable little tool, a way of generating some simple documentation very quickly. That way, again, remember that you don't just build these classes for your use. You build them for use of other developers as well. All right. And therefore, if we were on a programming team and I created my package and I would create, let's say, a customer class or whatever, if you needed to use that, it's nice to have this documentation for you to be able to reference. All right. We'll pick up next time. We'll survey JSP and Java servlets. We'll look a little bit at the Android development environment, and we'll come back and finish the creating of a jar. All right, we'll talk to you next time.